Hi, my name is Jihae, and today I'm going to talk about ChemCraft, an educational adventure game based on organic chemistry, specifically IB higher level organic chemistry targeting the niche field of games for higher education. The project asks not, what does a chemistry game look like, but instead, how can chemistry be a game, following Eric Zimmerman's ideas on gaming literacy. The design of ChemCraft follows the ludological definition of a game, as a rule-based formal system with variable and quantifiable outcomes. We thus view a real-world process, chemistry, with Ludic lens, to view chemistry as an opportunity for play, which too is a rule-based formal system, in which different chemical reactions yield different values such as new compounds, heat, and other particles. Now, before you understand the rules of the game, you first need to understand the context, atom by atom. The three interactive objects in the game can be divided into chemicals, little sentient beings that represent the chemical compounds themselves, the chemists who personify important chemical concepts like the Avogadro's mole, and experiments, which introduce the player in a turn-based battle pitting quite literally chemicals and chemical reactions against each other. The relationship between these game objects can be seen as experiments introduce conflict between the two chemists who have a collection of chemicals in their repertoire that can undergo chemical reactions such as combustion in a battle of knowledge. And all these game objects and events take place in an explorable world, very much inspired by chemistry. For instance, in this cityscape, the street lamps are lit by a literal neon electron diagram, which leads us into graphic representation to provide meaningful visual cues to chemical structures. For instance, methane has 4 little legs to represent its hydrogen atoms and a central circle to represent its carbon atom. Additionally, different types of chemicals are classified under homologous series, which are groups of chemical compounds with similar chemical properties. Graphically, I visualize the chemicals through this distinctive functional group, which here is color-coded and shape-coded accordingly. Within each homologous series, the different chemicals differ by a hydrocarbon, which increases their in-game health, because they have more bonds, and thus have higher bond enthalpy, and increases their damage because they can combust with more energy, both concepts that I'll elaborate on later. Which may bring you to question what this y-axis means, isomers. This refers to a chemical with the same chemical formula, but with different chemical structures. And actually, as the number of branches increases, the reactivity of the chemical decreases, which increases the in-game defense of the chemical. Now moving on to game rules. If chemistry properties are meaningful, then chemical reactions are meaningful too. For instance, chemicals react or attack using combustion reactions. However, the combustion depends on its reactants. If you don't have enough oxygen, the chemical will undergo incomplete combustion, which yields lower attack values or just be unable to combust. The number of oxygen molecules required comes from an important chemistry concept called balancing equations, so that the number of atoms for each element is the same for reactants and products. That is just one chemical reaction. I have also included synthetic routes and other chemical reactions as different battle moves in chemical experiments. Finally, you may have noticed that the numbers actually mean something in ChemCraft. For instance, this damage value from combustion is calculated from an enthalpy of combustion calculation for products minus reactants, and negative 1411 kilojoules per mole is how much heat 1 mole of butane would release under standard conditions. Even the so-called health is not random. This is calculated by the cumulative bond enthalpy in a chemical. The energy it takes to break all these bonds and dissociate the chemical into its atoms is its health, because if you dissociate the chemical into its individual atoms, it's basically dead. Lastly, I've conducted a pilot study with 5 participants, asking them questions from an IMI inventory for the usefulness of a game for education, their perceived competence, and their enjoyment of the game itself. This, coupled with a short free text custom questionnaire and a chemistry pop quiz, gave me an initial understanding for evaluating the game. The game was generally well liked by the players, commenting on either the gameplay or the graphics. 4 out of 5 of the participants commented that the game was initially challenging but had a learning curve, and the game taught players who initially had no prior knowledge of IB organic chemistry some new concepts, like compound notation or Avogadro's mole. And that's it for now. Thank you very much for your time.